Okay, so I just stumbled upon this concept called VortexNet, which uses fluid dynamics for neural computing. Wait, what?
Right? It's wild. The idea that we can use principles of fluid dynamics to inform neural networks is pretty groundbreaking.
Exactly. It seems like a totally different approach to how we typically think about neural architectures, especially with PDEs involved.
Yeah, and they're using these vortex layers to create a sort of fluid-inspired mechanism in autoencoders. It's like merging physics with AI.
So it's not just theoretical either. They've actually put together toy implementations in a GitHub repo for educational purposes.
Right? These implementations are more for learning than for any real-world application, though. They call them toy prototypes.
But doesn't that assume we can glean insights from these simpler models to tackle more complex problems later?
Totally, but we should be cautious. Simplified models might not capture all the nuances of real fluid dynamics.
That makes sense. I guess using these prototypes could lead to oversimplifications that might mislead developers.
Yeah, and the evidence for how effective these prototypes are in practice is mixed. It's a fascinating theory, but
Hold on, are there even practical applications for this beyond just academia? Maybe in robotics or simulations.
there's potential. Think about how fluid dynamics plays a role in robotics, especially in movement and navigation.
It's like if we could teach machines to think like water flows, adapting to their environment.
Exactly, but I wonder how scalable this concept really is. Can we build a vortex net that handles high-dimensional data?
That's a great question. The complexity of fluid dynamics might make it harder to scale effectively.
And it's not just about scaling. There's also the challenge of ensuring accuracy in reconstruction tasks.
Speaking of tasks, I saw they use the MNIST dataset for training. Isn't that a bit basic?
True, MNIST is pretty standard, but it's often a testing ground for new ideas before tackling more complex datasets.
So it's like a rite of passage for new methodologies. Start with MNIST, then move up to custom datasets.
Exactly. And their second script even allows for data augmentation and latent space interpolation. Pretty advanced stuff.
Wait, what's latent space interpolation? That sounds super cool.
It's where you can explore the space between different data points, generating new and interesting variations.
Oh, I see. So it's like creating a bridge between different images to see how they blend. That's fascinating.
Exactly. It could lead to some really novel outputs, but I wonder how well it works in practice.
Right, and with this focus on fluid mechanics, I can't help but think about the potential limitations.
For sure, the implementation might not accurately reflect complex real-world phenomena. It's a delicate balance.
So if we put all this together, what do you think the biggest takeaway is from VortexNet?
I think the main insight is the innovative merging of concepts from different fields, but it's still in exploratory stages.
And while it's exciting, we need to approach it with a critical lens, right? Not everything that flows is useful.
Exactly, we should stay curious but also grounded in what the data shows us. It's all about balance.
So could this actually lead to a new paradigm in AI, or is that too hopeful?
It's possible, but we need more rigorous testing before jumping to that conclusion. Let's keep an eye on it.
Definitely, it's one of those concepts that could either revolutionize things or remain a niche curiosity.
I love the blend of creativity and analytical thinking here. It's like the best of both worlds.
Yeah, and who knows, maybe the next breakthrough in AI will come from this unexpected intersection.
Exactly. Or it could just lead to more questions, which is just as valuable in the long run.
And isn't that what keeps the field so exciting? The constant search for answers to new puzzles.
Absolutely. Every discovery leads to another question. That's the nature of innovation.
So what's our takeaway? Fluid dynamics in AI is intriguing but needs more exploration and validation.
Yep, that's a great summary. Let's keep discussing and exploring these ideas as they develop.
Totally, there's so much to unpack here, and I can't wait to see where it leads us next.
Same here. Let's keep questioning and discovering. It's the best part of the journey.